Hello and welcome to the latest video supplement for my article Easy Entry as seen in Dental Lab Products magazine. This article pertains to the laboratory fabrication of implant Scanoguides. In case you don't already know, I'm Tom Zaleske, owner of Matrix Dental Laboratory and Consulting, and have been a dental technician for about 27 years. You can find me on Facebook. Just type in Zaleske Removable Prosthetics. Click on like and join the party. This is a new service comparatively to a lot of laboratories. Mostly removable laboratories will want to get into this because it has to do with that icky stuff called acrylic. Fixed laboratories hate to work with acrylic, that's a fact. Dentists hate to work with acrylic, yep. So do the assistants and ancillary people. But us removable technicians just love acrylic. Generally speaking, it's a planning tool for implant placement. You'll find different varieties, but they all accomplish the same thing, and that is to have a radio-opaque image of the restorative work that's going to be done so that this will aid in the positioning and placement of implants in the treatment plan. Come in a couple ways. One is a single gradient, and single gradient means that the only radio-opaque part of this appliance, which is a duplicate of a denture, is the teeth. There's no need to have any radio opacity in the base material, so consequently it's a clear acrylic. It could be a pink acrylic as well. We tend to use clear because it's aesthetically pleasing. A dual gradient style appliance is used in some applications, and dual gradient meaning two gradients, a 10% in the base and a 30% in the tooth intaglio. Guides can be made a lot of different ways for single tooth implant placement or multiple tooth implant placement. This here is an example of a finished guide. We have 3 teeth, all will be replaced, all will be restored with 3 single implants, and these Pontics here will dictate where hopefully the implants will be placed based on occlusal and aesthetic positioning. Just another example, a couple different guides. All have the same things in common, that being we have radio opaque Pontics that are in alignment with occlusally, and a stent which will hold those Pontics in position while there is a CT scan being taken. It's a one-shot, one-and-done type thing, hopefully. A little about CT scanning. It's a brand new, well, not brand new, but it's a new way of discerning where we're going to be placing implants, or actually where the oral surgeon will be placing implants. Here's an example of why it is a very important aspect. This would be a radio-opaque crown, and this is bone, and you can see the formation of the bone, the ridge. This gives you a better idea of how to place their implant, how they're going to place their implants. Let me show you what I mean. Here's one type of fixture, and you can see the problem with an overlay of where the fixture would be placed, and that is be a very thin area here in the bone, whereas if the selection was on a tapering type of implant placement, it allows for a nice amount of space between the bones, so we're not concerned about perforation. It also provides a closer approximation of the implant fixture to the bone height. All about sculpting emergence profiles and its relationship to the tissue. It's an invaluable tool. I don't know why more people don't use it. Well, I do know why, because it's a lot of cases it's cost prohibitive, but I feel that once you've decided to do an implant case from the beginning, oral surgeon, GP, and technician, the case should be treatment planned with all of these things that assure the success of the case. CT scans also help to discern quality of bone. This is just an example of a very thin mandible and the kind of things that they get to see when there's a CT scan done, which in the long run is going to help prevent a lot of problems in the future. Now, they're called radiographic stents or Scanoguides, either or. Let's talk a little bit now about the fabrication. Very simplistic. First, there's the positioning. Teeth are placed in an occlusal setting. In a lot of cases here, I'd have to have ground on teeth. I didn't see the purpose in grinding these teeth to bring them down, because we're really most concerned at this point with the placement of the implants and its relation to the bone height. And the lower, it's obviously much more exact. Anyways, we approximate the restoration positions, which I did. I kind of plotted out, look for the bone mass. I space it out. Nice thing about using denture teeth as the form for our Pontics is that we can select a tooth which is appropriate, both buccal, lingually, and mesial distally, and we can match up what's already exists. It makes it a lot nicer arrangement aesthetically. When I'm placing the denture teeth on the ridge in their position, I always make sure to sculpt them to exhibit an emergence profile. Try to follow the contour of the tooth and give it a nice profile of emergence. I wax it on the ridge. I use a little bit of regular base plate wax and a little sticky wax together, because later I'm going to put this in a hydrocolloid flask, and I don't want the warmth of the hydrocolloid to melt or move the teeth while I'm duplicating that. Duplication, as I just mentioned, if you're using hydrocolloid, make sure you wax your tooth positions in sticky wax or hard wax to avoid change. There are times when I'll duplicate using silicone. Here's duplications complete. We've duplicated this into a hard stone model. We'll put this model to the side because we'll later be making a clear matrix which will hold the Pontics in position, but we have to have a duplicate of what we're going to have in order to do that, and I'll show you what I mean in a second. Pontic fabrication using laboratory putty. The Pontics are underneath this putty, and we form the putty and make sure to take care to bring the putty down to the border. We want a nice index, in other words, because we're going to be removing those Pontics, and we want to have we're going to have a hollow mold, and we have to be able to trim that so we can put that back on the model in a very exacting fashion. Here's what I mean. We've pulled it off. I've removed the Pontics, and then what I'll do is I'll take and cut and trim this putty matrice so that when I fit it down on the model, it'll reveal the fact that it's seated without it standing up off the model. I then prepare some injection holes because I'll be mixing barium and acrylic or Scanocryl, depending on if you use the Scanocryl product or not. We'll be mixing that up, and we'll be putting that in a monoject syringe injector. They're very cheap and dirty. But before we do that, we have to put some ejection holes in these matrices because we're going to be filling those matrices with the barium infiltrated acrylic. The design as such is that I go low on the front side and high on the lingual side. I'll show you why. First I'll show you how I do them. A 5/16 drill bit and then a ball carbide just to open up the hole to fit the tip of the monoject in the front of it. I place, if this would be the buccal surface, I place the injection hole low on the buccal side of the model, and I call this the extrusion hole, high on the lingual aspect. So when I'm injecting the barium infiltrated acrylic, it fills to the top and then exudes out the extrusion hole. I'll on occasion, most of the time actually, when I start to get the extrusion out of the hole, I'll place my finger over that and I'll press on the monoject injector, and that's to make sure if there's any air or anything that it squeezes into place and pushes. I'll take my finger off the hole, of course, at that point, and then allow some more material to exude out. And what I'm doing is I'm clearing any possibility of air inside of there. I use Scanocryl. Here's our Scanocryl. I'm mixing it with self-cure monomer. This would be the 30% gradient material used for the tooth intaglio. So mix that up. Make sure it's at a little looser than honey. Pour it into your monoject syringe, and it should be that consistency. It should come out very easy with just a little bitty push. And then I place that injector tip into the mold, hold the model, and then I again squeeze until it begins to come out of that hole, and then I'll take my thumb and put it over that hole and squeeze a little bit more, because again I'm trying to force some of the air to this area, and then I'll take my thumb off and press it again, and if there's any air trapped in it, it usually extrudes out the hole. I want to make sure I fill that up. A lot of people are going to ask, well, why don't you just fill it with Scanocryl and place it on the model? And I just don't feel it's that exacting. I don't want acrylic on the teeth that I've used to index. I don't want acrylic running all over the place. This works really well. It's clean and it's much more exacting. Just took it off to show you after the fact, but I'll cure this on the model using conventional self-cure methods. Conventional self-cure methods are in a pressure vessel, a heated pressure vessel. Water should be about 120 degrees F. Keep it in there for about 25 minutes under about 20 psi. When you get through, it should come out looking like this, and then there's just a little bit of trimming to get it to shape. There it is, trim and fit to the ridge, and I evaluate the placement. Everything looks good. This Pontic area here, these Pontics should rest on the ridge in place, because the Emergence Profile is going to be on top of that ridge. It should balance quite nicely. It shouldn't fall off or anything, but that's just to check the placement. Then, as you recall, I duplicated those Pontics in position at the beginning. I take the model and trim it down so that I get a good vacuum forming, and I'm going to create now an occlusal retention or incisal retention matrix. I thin out the model as much as possible, and I'll use Proform 120 or 100 split material, which is PET, that's polyester terephthalate. And the reason I use that is because it has to have it's good to have adherence to acrylic, but it's easier for cyanoacrylate or other types of fastening materials to stick to it. It's clear and it's rigid, and the point of using the thicknesses here is to give it some rigidity, because we're going to be placing this over the top of the Pontics and affixing it to those Pontics, so that this will be used as a positioning matrix with the Pontics. I'll show you what I mean. Anyways, it's vacuum formed. And there's the model, and I pretty much, what I'll do is I'll I'll pretty much draw the guideline on the model to about the length I'm going to want the PET, and then I'll trim it back to that without the Pontics in place, because I want to make sure first that this is going to fit on the model without the Pontics, and if there are any obstructions when I place this over the Pontics, this way I'll be able to discern that. So here it is trimmed, it's on the model, matrix C is check fit. And then what I do is I'll take these Pontics and place them on the model, and then I'll lay this over the top of it just to check it, make sure it's nice and rigid. Then I'll take it off, and I'll put some super glue here. I like to put a little super glue on there, and then replace this matrix C on top and allow these to allow the cyanoacrylate or the super glue to set up. Some guys may want to use Scanocryl or other acrylics. I use the super glue. It's clear. It looks neat. The Scanocryl is going to run, may get over here, then you're going to have scatter wherever there might be acrylic that's run. So it's easier just to affix it to the PET with some super glue. So here it is in position, and let that glue set up. The material, by the way, that I'm talking about, is Scanocryl. It's available through a couple of sources. The reason that it was developed is because many times hand mixing, well, all the time actually, mixing the barium, and I had this problem myself. You're trying to mix the barium in with the self-cure resin. They're not the same grain size. They're not homogeneously mixed. It's just very difficult not to get scatter. Scatter being there might be higher concentrations of barium in one part of the Pontic and less in the other. This material is mechanically mixed at a factory. It's pulverized so that everything is the same grain size. It's very fast and very precise to use. You can use it with any self-cure monomer, and just a wonderful product. It comes in two gradients. For the 30% would be white for the tooth intaglios, and then if you're making a dual gradient appliance, and I'll show you that in a second, it comes in a blue, a light blue. That's to keep you from mixing up the gradients. If they were both white, it'd be hard to discern, and it's gonna be white on white. I'd rather have this be some sort of definition so I could see where the base starts, where the Pontics begin, not only in the radiograph but also in the actual materials. That Scanocryl product is available through Precision Ceramics Dental Laboratory. You all know Mark Jackson, I'm sure. He is a key opinion leader in the industry and on the cutting edge of CT scanning technology with the laboratories augmenting it. Effect Dental Products, that's me actually. I developed the product. You can also purchase it through me as well. Price is the same. Mark might get it to you a little bit faster. Anyways, here's our contact information for the Scanocryl. Here's the appliance complete off the model, and again this will fit nice and snug on here. Hold these Pontics in position so the CT scan can be made. Here's an appliance or a dual gradient Scanoguide that I would make based off of a diagnostic or an immediate denture or an existing denture. In this case it was requested I do a dual gradient appliance, 10% in the base, 30% in the teeth, and this will be consequently will be an implant bar, either a hybrid or an overdenture bar. But we have to have the positions of where the teeth are going to be so we can design the bar and place the implants. Dual gradient guides fill tooth intaglios and fill the base with 10%. Single gradient guides, which would be the clear base, would be 30% Scanocryl in the teeth, and the base would be with a self-curing resin, clear. Examples, dual, as you saw before, and you've seen this also. This is the single gradient, which would be just Scanocryl or just barium infiltrated acrylic in the teeth, and the base would be just clear regular resin, which has no radio opacity, and there's no worry of it interfering with the CT scan. The way I do it is I actually take the existing denture or the existing try-in once it's been approved for diagnostic reasons, and I encase it in laboratory putty. Here's the lower. I first invest this part into the tissue bearing side of the denture, and then embed that in the base, and then cover the top with a secondary layer of the material. And I use a standard flask, regular denture flask for that. I fetch that material out. I should probably go back there for just a second. I fetch the diagnostic out. I use 85 shore hardness. You could even use a little bit less hard material, because if you're going to be pulling full wax diagnostic arrangements out, you want to make sure you can get it out without breaking it. Anything more rigid than 85 is probably going to be a nightmare. You're going to end up breaking your diagnostic if it's in wax. So I suggest 85 and below. And then I would proceed, if I was going to make a dual gradient appliance, I would proceed in filling the tooth intaglios. I like using this putty and this flask technique rather than that clamshell thing that one of the manufacturers makes out there and you use alginate, because if I bone this any place along the way, I can basically take this out and redo and make a new one, and I have that luxury. With the alginate, I got to go through the entire process of covering everything with alginate again, opening the clamshell, fetching it out, and so forth. And the putty also imparts a nice smooth surface, whereas I see that the alginate tends to, the surface tends to erode a bit from the monomer you're using, because you're basically going to be taking, the way I do it anyways, is I do the dap and dish and drop wet brush technique, and I wet brush these in and then come back and I'll show you. But I use the wet brush to do the first filling. Well, I wanted to show you there's also products out there besides the putty that might be more cost effective if you'd like to try them. One would be the Lincoln Denture Guard material. I use that in my laboratory on occasion, and I wanted to illustrate that you could do this as well. Actually, this is an example of me making a duplicate denture. I've actually have a denture that's been completed, and I will cover it with the Lincoln Denture Guard material. It's an ice insulation paste. A lot of times, all the time, it's used for keeping stone out from between the teeth. But I'll cover this, and then I'll fetch the denture out, and I'll fill those intaglios and the base with pink acrylic and make a duplicate denture, and then void embarrassment denture, or whatever you'd like to call it, a spare tire from this. But anyways, you can also use it to make the Scanoguides as well. And I'll fill the occlusals first, as I mentioned, to show you using the Denture Guard material. Then, once they're filled, I go back and I add a mound of the powder over each intaglio. And I'll do that even when I'm making duplicate dentures. I'll take that. Now, what it'll do is it'll wick any of the moisture from that from the wet material that's already in there, and then I can take a brush, a number 2 sable brush, and some monomer, and just touch each one of these mounds. And because of the fact that most of it has been built up like it has, it won't slump when you wet it, because you want it to kind of stand up a little bit. You want to make sure that you have the margins all defined around the teeth. The closer to the shape of the tooth and the dimensional outlines, the better. Then I'll mix up my Scanocryl. In this case, it could be your self-cure resin, and I use I pour it in using this Flumi. It's a rubber bowl, and I mix it to a consistency that's pourable, a bit thinner than honey, pourable to the extent where you can get a stream. I hold the stream a little high to keep any air bubbles from getting in, and they usually air bubbles. You can see them here. They stay on the surface. They don't get buried in the pour. And I literally pour it until it gets to about this point, because I know that once I insert the ridge, this is going to push the material across, and this mold is going to be filled. And I'm trying not to overfill it too much because it gets a little messy. I always insert it with the front of the ridge in first and then down, rather than going straight down. It just helps not scrape anything, because there might be an undercut in the front of the ridge. So by going in and down on a hinge type action, front first and then down, that avoids that situation. And it's closed. I get a little mess here. It's a little bit of it oozing out of the sides. The 30% material should be rigid by the time you get through filling all the intaglios, and when you pour this in, this should not disturb it. I take a little paper towel, wipe this off once I get it clamped, and I literally, or generally, let it sit for about 20 minutes. I let it start to cure on its own a bit, and then I place it into about 130-degree water in my curing vat for about 30 minutes. Let the heat penetrate the mold so that it cures it, and then I'll break it out. And here is an example, the Scanocryl dual gradient material. This was a wax setup. You can see that was a real bear to get out without breaking it because it's on such a flared angle with the teeth. But I use it, like I said, a less stiff material. I was able to tease it out, and this is the guide. And this appliance will eventually be, well, this will be worn in the interim, and then this appliance will be a palletless bar case. I believe this one was a hybrid, and that's the way it looks. It comes out just like that. That's another case I did. Was both upper and lower. We did diagnostics first, and then use these guides to determine implant placement based on where we're going to put a virtual bar design in. And just a picture of the inside. You can see the homogeneity of the material. It's replicated extremely nice. I even have the post-am in from the original denture. You can see that this was an immediate denture. I think we left these in and then fabricated from there. So anyways, if you want to know more about how to do these types of things, besides fabrication, I also do education for groups and associations, departments, and individual laboratories. If you'd like to get a hold of me, here's my contact information. I'd be happy to talk to you, put something together for your laboratory, or maybe even a group of technicians just want to get together and have me come in and I can share some of these little techniques with you. Anyways, thanks for visiting my YouTube channel, and thanks for your attendance and watching this video. All the best and have a great day.